Okay, let's unpack this. You're gearing up for your ATPL theory exams, and, well, we know that feeling. It's like standing at the base of this massive mountain of information, right? And you need a clear, effective path to the summit. Today, we're taking a deep dive into something absolutely fundamental to piston engine aircraft, the propeller. It's not just about, pushing air. It's about a really finely tuned dance between engine power and aerodynamic forces, and truly understanding that dance is absolutely key to being an exceptional pilot. So our mission today is to distill the most important nuggets of knowledge from the sources we have on piston engines and propeller systems. We're going beyond just memorizing definitions here. We're focusing on what you really need to know for your exam, certainly, but also on giving you those aha moments. The ones that cement your understanding of both the whets and the why. Think of this as your shortcut to truly grasping the core principles, the intricate mechanics, and the operational nuances that turn raw engine power into the precise thrust needed for controlled flight. We're here to help you not just answer the questions, but to confidently apply this knowledge. So let's start right at the very beginning. When you look at a propeller, what exactly is its primary job? It seems obvious, maybe, but the physics behind it are surprisingly elegant and often misunderstood, actually.
Yeah, it's pretty amazing when you really think about it. The propeller's whole mission is to grab all that twisting grunt, that rotational power from the engine, and literally hurl air backwards. And that generates the forward shove we call propulsive thrust. What's fascinating here, and this is core physics, is that it's all fundamentally rooted in Newton's third law of motion. For every action, there's an equal and an opposite reaction.
Right, action reaction.
Exactly. So we're accelerating a relatively large mass of air rearwards, and the reaction to that is the forward thrust that pulls, sometimes pushes the aircraft through the sky. Now, it's worth noting that while it is an acceleration, it's not a huge acceleration compared to, say, the superheated gases blasting out of a jet engine. A propeller moves a large volume of air, but with a relatively small change in velocity, and that's actually quite efficient.
So the real takeaway here, especially for exams, isn't just what a prop does, but how it leverages Newton's third law, turning rotational muscle into forward push by moving that air. It's not just fanning aimlessly, it's proper engineering.
Precisely. That fundamental conversion of power to thrust based on moving air, that's your core concept. That's absolutely key knowledge to carry forward.
When you first see a propeller, it looks deceptively simple.
Yeah.
Just a fan, right? But when you start to break it down, it's actually an aerodynamic marvel, isn't it? Like a tiny rotating wing or set of wings.
Absolutely, and that's the key way to think about it. It's not just a paddle. A propeller typically consists of two or more aerodynamically shaped blades, much like miniature aircraft wings, attached to a central hub. This hub is then mounted onto a propeller shaft, which is driven by the engine. Now, understanding the specific terminology and geometry of these blades, that's absolutely foundational for your ATPL exams. Let's break down the nomenclature you absolutely need to recall. These terms will come up again and again. Okay, starting from the center, we have the root. That's the area where the blade physically attaches to the hub. Moving outwards, the tip is, well, logically, the outermost part of the blade. As the blade spins, the front edge that cuts through the air is called the leading edge, while the trailing edge is the rear edge where the airflow separates, just like on a wing.
Okay, root, tip, leading edge, trailing edge, standard wing stuff, basically.
Exactly. Now, if you just take a cross-section of the blade, you'll see it has a cambered cross-section, just like a wing running from the leading to the trailing edge. That curve is important. The forward curved side, which is essentially the top surface of our rotating wing, is called the blade back. Conversely, the flatter rearward-facing side, the bottom surface, is the pressure or thrust face. That's where the air pressure builds up to generate thrust.
Blade back, thrust face, got it.
Then right at the root, the round section that actually fits into the hub mechanism is known as the blade shank.
Yeah.
In the very base of the blade, where any pitch change mechanisms connect in variable pitch props, that's the blade butt. For your exam preparation, truly grasping these terms.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best.